Hello and welcome to this tutorial. In this tutorial we'll use a previously defined surface that was generated using a tailings deposition result file. We'll start by opening the dam breach base model. We'll use the module list box to activate the dam breach module. And we'll add a model by clicking the dam breach add model. This also activates dam breach functionality. For this tutorial we'll use default model settings generated when adding a model. To modify these settings, click dam breach settings. The model requires initial conditions which define the model state immediately prior to the run. For this model, we'll use the dam breach and tailings deposition depths, which are saved as values, to define the initial depths. Click dam breach, set value index. Retain the default value of 1 and click OK. The value depths are copied as initial depths to the dam breach model. We've now provided all the data required to define a model, but still need to validate the model. To validate the model, click the Validate button. Element shape errors are typically generated by breaklines that constrain triangulation or nodes that are too close to one another relative to surrounding nodes. To reduce the error count, we'll delete breaklines, audit nodes, and re-triangulate the model. To delete breaklines, click Surface, Break Lines, Delete Active Surface. To audit nodes, click the Audit button. On the triangulation warning window, click Yes. We'll audit the nodes to a 5 meter spacing. Revalidating the model indicates far fewer errors. To fix the remaining errors, click the arrow to navigate to the first node in the element that is generating the error. Zooming in on the element shows two nodes that are very close to one another. We'll address this by deleting the node and adding triangles. Click the Delete Row button. This deletes a node in the active row on the data grid and elements connected to that node. We'll add elements to close the area. Click the Element tab and the Add Element button. Click inside a boundary element, move to an adjacent boundary node, and click to add an element. Repeat this process to close the open area. You may also be able to swap element diagonals to increase internal angles. To swap a diagonal, click the Swap Diagonal button and click close to the diagonal. Repeat these operations until all element errors are resolved, revalidating the model from time to time to view remaining errors. Once done, click the Zoom Extents button to view the entire model. We'll hide the nodes and the element boundaries to show the topography. To hide the nodes, right-click on the data grid and uncheck Visible. To hide the element boundaries, right-click on the data grid and uncheck Element Border Visible. We now have a functional model which we'll save as Dam Breach Final Model. Having saved the file, we'll now run the model. Click the Run button. Enter a result file name to initialize the result file. You'll be prompted for an action if the file already exists. You can use the zoom buttons to adjust the view during the model run. To stop the model run, click the Run button again at any time. You are given the option to resume the run. The DTM view is updated to show the inundation extent. The model time is shown on the Results Summary window and results are displayed on the data grid. You can also view the model in 2 or 3 dimensions. Rotate the model using the Rotate button. Results are updated on the data grid during the model run. The model will run until the set time, when you will again be given the option to continue or finalize the model run. To view the results for any interval, click the Dam Breach tab and select an interval from the list box. The DTM view is updated to show the inundation extent. Click the Dam Breach Result button to show or hide results. Click at any point in the model to view the flow parameters at that location. That concludes this tutorial on defining a dam breach model. Thank you for taking the time to watch this tutorial.